Okay, for this video, we're going to talk about the anatomy of a wave. So what are the parts of a wave? And specifically, you can see here we're going to be dealing with transverse waves, okay? So our first one here that we have is this crest. So it says the highest point of the wave above the line of origin. So that's going to be 3. Sorry, it's going to be 5 right here, right? But it's also, this is a crest, anytime it's the highest point. That's always a crest, okay? Trough, lowest point of the wave below the line of origin. That's going to be here, right, number 2. And then we're going to have, and then of course these are troughs as well. This is a trough, okay? So anytime it's the lowest point. And then the line of origin, that's just this line right here, the x-axis, okay? So we'll call that number 1. For the wavelength, okay, so that's what number 3 is. So we can see that there's a crest to another crest. So anytime you have a wavelength, it's one complete wave. So notice the wave goes all the way down and all the way up here. And so you have a full up and a full down. But you could also do trough to trough. That would also be a wavelength. And you can do this and go all the way to the point where it goes back here, right? So see how this line was coming up here? And then how it's coming up here, that is also a wavelength, okay? So this would be one wave. So we'll put 3 here. Let's do this in a different color, let's do like pink or something. So we'll do 3 here. So that's a wave, but also that's a wave, right? Right there, that's a wave. This is a wave. You can do it really anywhere. You could even, if you wanted to, go from here to here. You're just, the main point of a wavelength is you're getting back to the starting point of the wave. Wherever you started from, go until it's the next starting point. So that's wavelength, right? And I would recommend doing it this way. So a lot of the waves, they kind of start here at the origin, and then they go this way. So if you do trough to trough, you're going to miss how many waves are here, right? So if you count crest to crest, you have 1, 2 waves, okay? But we have more than 2 waves here because we didn't count any of this, we didn't count any of this. So if we count this a little more accurately, right, let's actually count these wavelengths and see how many waves we have here. So let's start from the very beginning. We have 1, 2, 3, right? So we actually have 3 full waves here. So you need to be careful when you're counting your waves, okay? All right, so then amplitude. So amplitude is what we have here on number 4. Let's go back to, let's do green. So amplitude is 4, and so of course that's this distance, right? So notice that this is not the amplitude. It's not all the way from the top to all the way to the bottom. If you put that, you're going to get it wrong. So if we had some numbers here, like 5, 0, -5, the amplitude for this wave is just the distance here. So it would just be 5. It would be amplitude of 5. And then this would also be the amplitude, right? You can also go from the origin to the top, and you can see it's still 5, right? So the amplitude for this wave is going to be 5, not 10, right? That would be like if you went all the way from top to bottom. Okay, and that's pretty much it. And then another concept we need to know for waves is frequency. So frequency is basically how many waves are going by per second. So in this example, right, like let's say that this was a picture of a wave or a video of a wave that happened over 1 second. Well, frequency is basically waves per second, right? So you would have something like F equals waves per second. Well, we just said that we had 3 waves here. So our frequency would be 3 waves for every 1 second. So our frequency would be 3. So if we wanted to show like a lower frequency wave, we would maybe cover up some of these waves and maybe we'd only have 1 or 2 waves, right? Whereas if we wanted to show a higher frequency wave, we would draw way more waves in the same amount of time. So typically the way we would draw a low frequency wave would be the waves are spread out, and then high amplitude, of course, means that they go far up and far down. So these are like really spread out waves, so that tends to be a more low frequency. So this one we're also going to draw a high amplitude, but we're going to draw high frequency. So that's what this kind of looks like. So you can see the amplitude is about the same, right? The up and down are about the same, right? But look how many more waves we have in this one compared to this one. We only have like 1.5 waves on the top here, but we have like 1, 2, 3, 4, 4.5, 5 waves on the bottom. So way more frequent. There's a lot more waves going by. So if both of these happened over 1 second, you could see how the frequency here would be much higher because there's more waves. And that's pretty much it for that.